All right, we've moved on to part 2 of our lesson, and it dawned on me that it would have been really nice if I had talked about examples of irrational numbers when we were doing part 1. So let's go ahead and look at a few. So remember, irrational numbers are numbers that cannot be written as a fraction of or a ratio of one integer over another. So examples that you're probably familiar with would be pi, square root 2, square root 3, square root of anything that's not the square root of a perfect square. So if you think about writing a rational number in its decimal form, anytime you write a rational number in its decimal form, it's going to be a terminating or repeating decimal. Now, I know that in middle school you tend to work a lot more with decimal numbers than we do in high school, and so you want to kind of switch your brain into thinking about numbers in fraction form or rational form more so than decimal form. For example, I don't use this very much, if at all, okay? I use 1/3. So we don't want to get stuck on decimals. Let's focus on fractions. Fractions are our friends. So then if you have an irrational number in decimal form, they are going to be non-terminating and non-repeating. So that's what you would find if you were looking at the decimal form of pi or square root 2, square root 3, etc. Non-terminating, non-repeating decimal numbers. Okay, let's move on to part 2 of our lesson. So we're looking at properties of real numbers, and I suspect that you're very familiar with some of this vocabulary, and there might be a couple of them that are new to you. So let's take a look at the general statement. If A equals B and B equals C, then A equals C. So that we know as the transitive property of equality. And because you most likely had geometry last year, you probably used some of these properties fairly often. I'm just going to abbreviate transitive prop. So let's look at an example. If x equals 3 and y equals x, then y equals 3. All right, the next one shows that if you're multiplying a number a by a quantity b plus c, and that could also be the quantity b minus c, it could be addition or subtraction there, then you get a times b plus or minus a times c. And we know that as the distributive property. Notice the mathematical operations involved in the distributive property. You have multiplication, you have addition or subtraction. One of the main reasons that people tend to make algebraic errors in all levels of math is abuse of the distributive property. Okay, we don't want to abuse the distributive property. So if you had something like A times B times C, that's not multiplication with addition and subtraction, that's multiplication with multiplication. So it would not be true that you would get A times B times A times C, okay? So be real careful with the distributive property. Does it say that if you have A plus B raised to the C power, that it's the same as A to the C power plus B to the C power? Does it say that? Is the distributive property used for addition and exponents? It doesn't say that. It says multiplication and addition, subtraction. So be real careful that you don't overuse and over-apply the distributive property. Okay, the next one shows there's two different cases here. We see addition only, we see multiplication only. So here's how I like to think of this one. You have B. B has turned and talked to A first, leaving C ignored. On the other hand, you have B. B has turned and talked to C first, leaving A ignored. You know what? It doesn't matter. Those are both the same thing. A has talked to B, B has talked to A, B has talked to C. It just happened in a different order. We call this the associative property. I like to think of it as B is associating with A first, or B is associating with C first. So an example of this would be 5 plus 3 plus 2 is the same thing as 5 plus the quantity 3 plus 2. Either way, you're going to get 10. Now we also have the associative property of multiplication. So an example of that would be 5 times 3 times 2 is the same thing as 5 times 3 times 2. Okay? Let's move on to the next property. We have a property for addition and a property for multiplication again. Notice that the numbers have switched places. So I think of this as like going from home to work and going from work to home. You switch places. You switch around where you are. Now, what do we call the process, especially if it takes a long time to go from home to work or work to home? We call it commuting. So this one is the one that we know as the commutative property. Okay, an example for the commutative property under addition would be 5 plus 1 equals 1 plus 5. And an example of the commutative property of multiplication would be 5 times 2 equals 2 times 5. Switching the order does not change the value of the expression. Okay, we have 4 more. At this point, we're taking a look at 2 of our favorite numbers, 0 and 1. We love 0, we love 1. They make our lives so much easier. So we know that a number plus 0 is just the number. A plus 0 is A. And it doesn't matter if it's 0 plus A or if it's A plus 0, either way, you just get A. So 0 is known as the additive identity. If you add it to something, you get the identical thing. If you add it to A, you get A. If you add it to 12, you get 12. Now, if you take the number A and you add something the opposite of A to it, you get the additive identity. You get 0. So the opposite of A is known as its additive inverse. Inverses in math kind of undo one another. The opposite of A is the additive inverse of A. Notice I'm being careful to say the opposite of A instead of negative A, because what if A is a negative number? What if A is negative 7? Then what is its additive inverse? Positive 7. So the opposite of a number could be a positive. So an example, you have the number 42. You add the additive inverse, negative 42, to get 0. Okay, now on to our other favorite number, 1. So remember, up here we said that 0 is the additive identity because when you add it to something, you get the identical thing you started with. So what would we call 1? Not the additive identity, but the what? Very good, you got it. The multiplicative identity. 1 is the multiplicative identity. And by the way, these are the properties of real numbers. So this wouldn't work if we weren't talking about real numbers. And I started talking and stopped writing properly. 1 is the multiplicative identity. And then, if you have a number A, and you multiply it by this thing here, this thing that's the reciprocal, you get the multiplicative identity. So yes, 1 over A is the reciprocal, but it also has a different name. And if you think back to what we did up here with A and the opposite of A being additive inverses, A and 1 over A would be what kind of inverses? That's right, multiplicative inverses. So 1 over A is the multiplicative inverse, which is also the reciprocal. Oops, I left out a letter there. Of A. All right. So, I'm going to give you your assignment now, and I want to remind you that once you finish the assignment, which comes from our book, but you don't have your book yet, so you're going to see that I uploaded some pages onto Canvas that will just be the pages from the book. These problems are just a variety of problems from the first half of the chapter. I want you to check your answers. I've provided the answers. And remember, when you uploaded your assignment, I should see your notes, your worked out problems, and evidence or markings showing that you have checked your answers and that you've corrected your mistakes. So really it's up to you what you like to do. Do you like to put a star by things? Do you like to put a check mark? Do you like to put a question mark by something or circle it if it wasn't right? And then, of course, if you had a question mark or a circle, you're either going to figure out how to correct it yourself or you're going to get some help from someone. Maybe you need to wait until class the next day and ask me questions about it. That is totally fine. And so I'm not expecting everybody to upload the assignment before the next class period. I'm hoping that you'll upload your assignment when everything has been resolved. So if you have everything resolved, everything's good, you worked it out, you checked your answers, you have no questions, go ahead and upload it whenever you're ready. If you have questions remaining that you still need to ask, then you don't need to upload it yet. Okay, thanks everybody. And remember, you can always check back with me in our Zoom meeting during the course of the period if you get stuck on anything or you have any questions.